All right, well, welcome everybody to math.
Lesson 9.
9. Inference for one mean sigma known. So first off, how was the exam for everybody?
I don't want to talk about it. So that's how you know how I did.
I wish you could go back and see what you got wrong.
Yeah, for real.
Because I thought I did okay.
Yeah, I was thinking about that, but can you imagine if they did? Because we could easily tell our,
Yeah.
Not that we would do that, but I'm just saying that's probably why
They'll eventually open it up where we can see the answer.
Yeah.
I hope.
I thought maybe after the time, like after the day.
That's true.
I guess I haven't checked it since then, though. Let's see. Nope, still can't see it. Oh well. Yeah, kind of bummer that it's not working, but. All right, so how did you guys do in the preparation? Whatnot? Any questions?
I read the chapter, but I didn't do the assignment.
And I skimmed the chapter, watched the first video, and I did most of it. Yeah. What about you, Leah?
I read half the chapter, watched the 2 videos for the chapter, and then watched the first part of the homework videos, or the video 1 for the homework videos. The tutorials, the one that walks you through the prep assignment.
The best ones, I think. Yeah, I didn't look at that one yet. To me, it's a little confusing. I think, the matrix of the hypothesis, the null hypothesis versus the alternative, right?
Mm-hmm.
I mean, it's easier, I think, than I'm getting it. Like you just look at where type 1 is, and you look at where type 2 is, and I don't know. It's just a little confusing to me. That's what I'm trying to say.
The wording of things.
Yeah.
Just hard to wrap your head around.
Mm-hmm.
Yeah, like why do they have to say fail to reject instead of accept? And reject and fail to reject. I mean, that's just kind of confusing.
The chapter talked a little bit about that. It talks about how you can't really, like, science isn't about proving that something is right. It's about proving something is wrong.
Okay.
Like it gave the example of, I think it was Einstein's theory of relativity. And it's like, we don't know for sure that that's right. It's just we haven't been able to prove it wrong yet.
Okay.
So I think that's why it's failure to accept or failure to reject the hypothesis.
I guess for me, I just don't really understand why you have the different, like why you have the null and the alternative. Why don't you just have one? Like, let's see what the body temperature is, But I know what you mean, Jody, when you don't understand it. And sometimes I get it, and then I'll read a little bit, and then I'll forget. Right? But the more I've gone over it, the more I've been able to understand it.
That's good. Yeah, I thought it was kind of confusing too, but I also didn't get to read the full chapter, so I'll go back before the homework quiz.
Yeah, even if I do read it, it takes a while to sink in if it ever does. You know what I mean?
Yeah.
It's statistics. I mean,
Well, do we want to go through the quiz and we can work on those problems together and then just ask questions as we go this time if we don't understand something?
Yeah, I think that sounds good.
yeah, that's great.
So you want to do the group meeting quiz right now?
Sure. Are you okay with that?
Yeah, I'm fine with it.
So I think the first one, is everyone there?
Mine's still loading.
It's loading.
There we go.
I should prepare by just having that sheet right there, but I never am. Okay, I'm finally there. Let's see.
I just read this.
So I think it's the null hypothesis.
Yeah, it is.
Yeah.
The p-value is... Isn't it null again?
Yeah.
For question 4.
Yeah, because null is the one that you assume to be true, right?
Yes, I want to say.
I feel like it's the alternative.
Well, shucks.
No, I don't. Okay, let's see. The p-value is the probability of obtaining a sample.
Oh, assuming the null hypothesis is true. Oh, so I think it is the null.
I'm not confident.
It says at least it's extreme, assuming the null hypothesis is true.
Mm-hmm.
Oh yeah.
And I think that was part of the prep assignment. One of the questions asked which hypothesis is true, and
It's null, right?
yeah.
Okay.
Yeah.
I think I'm just confused because later on in the assignment it says the p-value is determined using the alternative hypothesis.
This lesson was confusing.
What?
And that was in the lesson?
Yeah, it's in section 4.3.2.
And then 4.3.1, that's where.
Yeah, that's where it has
So one's 4.3.1, 431 definition, and then the other one has to do with the alternative hypothesis.
The number 6 in the assignment says p-value is the probability that that's under the solution. P-value is the probability that you will observe the sample test statistic you did, or one more extreme, assuming the null hypothesis is true. Is it saying that? Is it saying that? Number 6?
And then there's another problem that deals with using the alternative. So I think for this one, it just wants to know which hypothesis we assume to be true.
Oh my gosh.
Which would be the null.
Yeah.
And then...
Yeah. We assume that the null hypothesis is true when we compute the p-value. That was it.
Josh, you still think it's the other one?
No, I'm just trying to work through it in my head. Like, it makes sense from the reading because it explicitly says assuming the null hypothesis is true, whereas later on it just says determined using the alternative hypothesis. It doesn't say that the alternative hypothesis is true. I think it is the null.
Okay. No, it's really confusing.
It is.
The next one is which of the following represents the alternative hypothesis for a two-tailed test?
That's equal to, right? The last one?
The not equal to. Oh wait, shoot. They're all A, but isn't the null the only one with just equal?
Yes.
Okay. That's tricky.
And then if it's less than, then that means it's to the left. And if it's greater than, that means it's to the right.
It's right-tailed.
Yeah.
Yeah.
So alternative is the not equal to or the equal to? Which one did you put?
Just the not
equal. Yeah, so for 5, it's the one that's not equal to.
Okay.
And 6, it's the alternative for a left-tailed test.
The less than.
Which is less than. No? Yes?
Yes.
It's eating the 10, right?
Yeah, I always have to turn it into an L. I'm like, which one is the L? That's less than.
Yeah, I know. I struggle with that too.
Wait, so it's the first
top one.
Yeah.
Right? Yeah.
Yeah. And then the next one is asking for the right-tailed test, which would be the opposite, or the second one down.
Right.
All right, so that little sign is the level of significance, right? The A. Oh, yeah, it says right there. Okay, value level of significance.
Which relationship is
I think the Z is trying to confuse us, right?
I think
tricking our heads.
Yeah, I think 8 is that the p-value is greater than alpha. I think.
So the top one.
So there's a memory aid in the chapter that says if the p is low, reject the null. Wait, that doesn't have anything to do with alpha. Just kidding.
That was a true statement. It's like, I remember that.
Okay, if the p-value is less than alpha, we reject the null hypothesis. Conversely, if the p-value is greater than alpha, we fail to reject the null hypothesis.
Okay, so yeah, I was right. I just couldn't put it in words.
So you were right.
Was.
Yeah.
And that's
then the next one.
Sorry, that's the p-value is greater than.
That's the top answer.
Yeah.
Yes.
Okay. Cool.
And then the next one is the second, the less than.
Right.
The opposite.
And we know that because it says it's asking us if it's rejecting the null or failing to reject.
So we reject the null if the p-value is less than alpha, which is usually it's 0.05.
That's right.
So they're concerned that the true mean is higher than this. Would 10 be the average claim amount is greater than 1,500?
That's what I think. Because they say they're concerned that the true mean is actually higher and not just different.
Right.
Yeah. Because it would say if it said the same or less than. It doesn't say that. So less than, not equal to. Yeah, I think it's greater.
And then the next question, number 11, is asking for the null hypothesis.
So it would be equal to 1,500, wouldn't it?
That's what I think.
Yeah.
Okay, the insurance company randomly selects 40 claims and calculates a sample mean of 1,650. Use this information for the next questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
I'd say it is because the sample size is large.
Yes.
Yes.
Because we don't know anything about the population. We just know about the sample size.
What theorem or law justifies your answer to the previous question?
Central limit theorem.
Central limit theorem.
Yay!
That's one that we got from our other stuff.
Yeah.
What is the test statistic? Is it the S?
The test statistic, assuming we assume the mean is absurd. Where Z is the test statistic.
Oh. Never mind. So it's Z?
Yeah.
That's what I read it from the book, where Z is the test statistic, and then it keeps going.
Right.
So we need to find Z. Okay. Oh, no. But are they going to have us find it? Yeah.
Of course.
What is the Z-score?
So our n equals 36, right?
Uh-huh.
Divided by, oh wait, no, not 36. The standard deviation is 40. You guys get negative 0.9.
Yep.
You guys got negative 0.9.
Yeah.
It says 3 decimals, so do we put 0.900, right? Hmm.
So if it's negative 0.9, does that mean when we put it in the applet, don't we?
Uh-huh.
Physics 4. So would that mean that we only look to the left of negative 9?
Yes, because it's
Okay. Negative point.
left tailed. I got 0.184.
That's what I got.
Yeah.
The p-value.
Yep. What inference would you make about the null hypothesis? This problem.
fail to reject it. Since it's greater than 0.05.
So when it's greater than 0.05, you reject the null. And when it's less than 0.05, you fail to reject the null. Correct?
I think it's switched.
Okay, I'm gonna find it. I was looking through the text. I'm gonna do it.
If you look on the, at the bottom, how it has the summary box,
Yeah.
the fourth bullet point, the last sentence says, if the p-value is less than alpha, we reject the null. If the p-value is not less than alpha, we fail to reject the null.
So it's not less than. Wait, the p-value.
Yeah, so since the p-value is 0.184, that makes it greater than alpha.
Yeah.
Then fail to reject the null.
Okay. Yeah, because it's higher. Let's-
What is your conclusion for this problem?
So if we're failing to reject it, that means we have, let's see, failing to reject it.
Would it be that we have sufficient evidence that the true population mean is 150? Or insufficient?
That's what I was going to say, but this stuff is so confusing. That was my first.
No, I was like sure of myself, but then I was like, wait, nope.
No.
Because, okay, so the null is that it equals 150. The population is 150. And so we're failing to reject that, which means that we're saying that it is 150.
Yeah.
Yeah.
Be sufficient evidence. I think it is. I think so.
That the true population mean is 150?
Yes. We have sufficient evidence that the true population mean is 150.
All right, let's go for it.
Which there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
It's type 1, right? I'm just looking at my little
Mhm.
chart. So type 1, yeah.
Yes. Researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true?
I remember reading this, but I don't remember what it said.
Yeah. So if they change it, let's see. I don't know for sure. Probability of a type 2 error will increase. Let's see. Research.
Okay, if the A value, the alpha value, the probability of committing a type 1 error is very small, the probability of committing a type 2 error will be large.
Yeah,
Conversely, if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small.
Where's that at?
Under 4.5, type 1 and type 2 errors. It's underneath the little chart.
Okay.
Huh. Yeah.
So the probability of committing type 2 error will increase.
Yes.
yeah.
The type 2 error?
Yeah, that's what I think too. The second answer.
Yeah. Oh.
Oh, how do you do that?
I think it's 0.05. Because in that same section above the chart, it says we choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is alpha equals 0.05. This is equal to 1 over 20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance.
So you think it's the same? 0.05?
It sounds the same. It sounds like
Yeah, because it's 20%.
Yeah. I don't know how else to calculate it.
Yeah, and it's 2 decimal places. So, that's a chart.
this has just been a tricky tricking us all over the place.
Okay.
We have faith in you. You get us 100% every time. So
All right, I'm submitting it.
No!
Did we get one wrong?
What is your conclusion for this problem? It's question 18, and we have sufficient evidence that the true population mean is 150.
Oh,
And that's not right.
well, I haven't submitted mine yet.
Okay,
So.
don't submit yours. I mean, it's not wrong, but if you could give me the answers, and then we can go back over 18.
Oh, yeah.
Can you
look
redo
at
it?
our previous attempts.
Oh, that's true. Yeah, I'll just go through and redo it after our meeting. But, I was just saying we've never gotten one wrong.
no, I jinxed us. So
So
what is your?
that we have insufficient evidence?
I didn't submit mine either, so I can submit it and see. Do you want me to?
I would say it would be that, the insufficient.
Yeah, I think that's
Insufficient evidence that the true population mean is less than 150. So then it's okay. I'm just gonna.
Is less than 150?
Oh wait,
Or
no.
would it be
It is 150.
the top one. The true
Yeah.
population
Yeah.
mean is 150.
really know either, but I'm just going to try and see.
Is that the only question that we got wrong?
I think so. Let me look just to make sure though, but that's the only 0 I saw when I was scrolling through. Yep, that's the only one.
Here.
Other than that, it was 22 out of 23. So
Okay, here we go. So 18. Oh, it's wrong.
What?
No, we have I thought we had sufficient evidence. So
So
maybe it's
we have sufficient evidence that the true population mean is less than?
we have insufficient evidence that the true population mean is less than 150. Wouldn't that be a true statement? Because if we rejected, or if we failed to reject the null hypothesis, means you don't have sufficient evidence to, to prove that population mean is less than 150, because that was the alternative hypothesis. Does someone want to try it?
Well, I haven't submitted mine yet.
oh cool.
I'm just
Then,
gonna
if you submit it, that gives us one answer left. Yeah, this is so confusing. I don't know.
I'm just writing down the answers real quick. All right. So for 18, we have insufficient evidence.
So it's not number 1, and it's not number
2.
What else? Yeah, number 2. So Leah, which one do you think it is?
I thought it was insufficient evidence that it's less than 150 because we failed to reject the null hypothesis. But I'm not 100% right. But like you said, we got one last option. So
put the third one, Jared.
Okay, I will.
Thanks, Jared.
And it was right.
Oh, yay, Leah!
I'm gonna go back in and retake it.
So we have insufficient evidence that the true population mean is.
So the third one.
Yep.
Oh, good heavens. Okay. All right.
Well.
Thanks, everybody.
Yeah. Good teamwork.
Onward and upward. Yeah.
And hopefully my camera will fix itself by Tuesday.
Yeah, because we need to see you. It's not right. Nope.
All right.
All right, thanks, guys.
Thank you. Have a good night.
You
Bye.
too. All right. Bye.
Bye.